In section 1.2, you will convert between fractions and decimals. So you'll convert from a fraction to a decimal and from a decimal to a fraction. This is all stuff that you've done in the past, so this section should be a review for you. So recall from section 1.1, rational numbers are any number that can be written as a fraction. So if a number can be written as a fraction, it's rational. So that would be any of those decimals that terminate or end, any decimal that repeats, any fraction, any whole number, or percent. A fraction means the same thing as division. This is going to be very important to what we're doing in this section, so you need to make sure that you really understand. A fraction is the exact same thing as division. So on the front of this, we're going to convert from a fraction to a decimal. Now there's kind of two ways that you can do this. I'm going to tell you the first way, which can tend to be a shortcut, and then the second way is always a backup plan. It'll always work. So the first way is to convert the denominator to a place value. So get the denominator to be 10, 100, 1,000, or so on. So that would be a multiple of 10. I'm going to work on this first example with you. So we can get 25 to become 100 by multiplying it by 4. If I multiply 25 by 4 to get 100, I have to do the same thing to my numerator. When I do that, 12 times 4 is 48. So now that my denominator is a place value, my numerator is now my decimal. So 12 over 25 is the same as 48 over 100, which is the same as 0.48. Let's look at the next problem. 32 over 40. Well, I cannot multiply to get this number to be 100 or 1,000 or anything, but I can divide to get this denominator to go down to 10. I can divide by 4. When I do that, 40 divided by 4 is 10. I'm going to do the same thing to my numerator. 32 divided by 4 is 8. Now that my denominator is a multiple of 10, my numerator is the decimal. So 32 over 40 is the same thing as 8 over 10, which is the same thing as 0.8. Now, if you're dividing, you're not always going to be able to divide to get an even number like 8. Or maybe you just don't see that that's an option. And sometimes it's just not an option to begin with. So we need to have a backup plan for when converting your denominator like that does not work. So we are going to long divide. So when we long divide, we're going to take our numerator and put it inside the division, and the denominator goes outside. So I'm going to move over to the side, and I'm going to work on 32 over 48. So this is that problem that 32 over 40. This is that problem that we just did. And since you might not see that you can make 40 a denominator of 10, or if that's not an option, we need to be able to do this. So I'm going to write out my division, and 32 is going to go on the inside. Top number goes in, 40 goes out. Now when I work this out, 40 cannot go into 32, so I have to add a decimal. When I do that, I must line it up here, and a 0. 40 goes into 320 8 times. 8 times 40 is 320. So I'm going to subtract to see that there's 0 left over, so I'm done with this problem. So 32 over 40 is the same thing as 0.8, which is what we got down here in this example as well. So we have one more that we're going to work on. 4 over 9. Well, I cannot make 9 into a multiple of 10, so I'm going to work this division out. 4 goes inside, 9 goes outside. Top number goes in, bottom number goes out. 9 cannot go into 4, so I have to add a decimal, line it up here, and add a 0. 9 goes into 40 4 times. 4 times 9 is 36. I'm going to write that and subtract. When I subtract this, I get 4 left over, so I need to add a 0 and bring it down. Now I'm noticing that this is starting a pattern. 9 goes into 40 4 times, and this pattern is going to continue. So it's repeating. So 4/9 is the same thing as 0.4 repeating. Now I'm going to tell you, when 9 is in the denominator, it's always going to be repeating. 9 is our magical number when we're doing conversions. 9 is the denominator, always means repeating. So what I'm going to have you do is we're going to go down to the practice problems at the bottom. Go ahead and pause this video, work out those problems, and make sure that you are able to do them on your own. Once you've got them, play the video and I will walk you through how to do these problems. So we're going to start on 3/20. Now I notice that I can multiply my 20 by 5, and I'll get a denominator of 100. So that means I'm going to multiply my numerator by 5 as well to get 15. And now since my denominator's a multiple of 100, or a multiple of 10, then the numerator's now my decimal. I could also have long divided this. I could have put 3 inside and 20 outside. 20 does not go into 3, so I'm going to add a decimal with a 0. 20 goes into 30 one time. 1 times 20 is 20, so I'm going to subtract to get 10 left over. Add a 0, bring it down. 20 goes into 100 5 times. 5 times 20 is 100. I'm going to subtract to get 0 left over, so I'm done. Whichever method you use, you end up getting the same answer. All right, now we're going to work out 1/7. I cannot make my denominator a multiple of 10 with this problem, so I just need to do long division. So I'm going to set up my division. 1 goes inside, 7 goes outside. Numerator always goes in, denominator always goes out. 7 cannot go into 1, so I'm going to add a decimal, line it up, and add a 0. 7 goes into 10 one time. 1 times 7 is 7, so I'm going to subtract to get 3 left over. I'm going to add a 0 and bring it down to continue this problem. 7 goes into 30 4 times. 4 times 7 is 28. I'm going to subtract to get 2 left over. Add a 0, bring it down. 7 goes into 20 2 times. 2 times 7 is 14. I'm going to subtract. I get 6. I'm going to add a 0, bring it down. This is still going with no repeats, so I'm going to continue on with this problem. 7 goes into 60 8 times. 8 times 7 is 56. I'm going to subtract to get 4 left over. So I need to add a 0, bring it down. Now at this point you might be thinking that this is going to go on forever. But remember that 1/7 is a fraction, which means that it's rational, which means that this is either going to end or repeat. So we just need to keep going. So 7 goes into 40 5 times. 5 times 7 is 35. So when I subtract, I get 5 left over. I'm going to bring down a 0. 7 goes into 50 7 times. 7 times 7 is 49. When I subtract, I get 1 left over. Now I see that this is going to start repeating. So this whole decimal is repeating. So this is my final answer. All right, one more problem. 12 over 99. I could long divide that, but I could also notice the 99 in my denominator, which just means that 0.12 is going to be repeating. Whenever you have a 9 or multiple 9s in the denominator, the numerator is always repeating. So it's going to be 0.121212 going on forever. Now what I need you to do is pause this video and fill out this ladder chart. Now the reason you're going to do this is because you're going to see these fractions a lot in the next couple of sections. So, and they're ones that you can memorize. And if you do that, it's going to make your life a whole lot easier. So go ahead and fill this out. And then I will fill it out as well. So you can pause the video, fill it out on your own, play the video, and double check that you got all these correct. And then study this and memorize it to make your life easier in the next couple of weeks. All right, go ahead and take a moment to double check that you've got all these. Notice that when there's an equivalent fraction, when the fraction can be simplified, I wrote that in there so that you can kind of make connections between some of these different fractions. Also, I want to point out that in this box up here, it's reminding you that when 999, 999, etc. is in the denominator, that means the numerator is repeating. So that's like this problem that we did down here, the 12 over 99. There is a 99 in the denominator, which just means that the numerator, the 12, is repeating. Go ahead and flip your paper over now, and we're going to work on the back side of this, which is converting decimals to fractions. So just like there's 2 ways to convert fractions to decimals, there's also 2 ways to convert decimals to fractions. The first way is to use the place value as the denominator. The second way is to use the amount of decimals as the amount of zeros in the denominator. So on these 2 ways, you're actually doing the same thing. It's just thinking about it differently. So let's start with place value. We're going to convert the number 0.8 to a fraction using place value. So we have a few different steps that we need to go through here. The first step is to figure out what the farthest right place value is. So for your convenience, there is a place value chart here with a decimal. We're focusing on the decimal portion of the place value. So if I have 0.8 written in here, 8 is the farthest right number. It's in the tenths place. So the place value is tenths, or we're going to focus on the 10 part of that. We are going to use that as our denominator. So when we set up our fraction, 10 is the denominator, and then the decimal is just our numerator. And then our final step is to simplify the fraction. So with the fraction 8/10, we can divide both the numerator and denominator by 2 since they are both even. 8 divided by 2 is 4. 10 divided by 2 is 5. So 4/5 would be my final answer. I always want you to simplify your fraction. Your answer should always, always, always be simplified. Our next way that we can think about this problem is just by counting numbers and by counting zeros. So the first way was actually using place value. Now I'm going to go through the steps for counting zeros. So once again, we're going to convert 0.8, but this time we're going to be converting 0.8 by counting zeros. So the first step is to count the amount of numbers after the decimal. So if I have 0.8, there's only one number after the decimal. So the second step tells me that I'm going to have 1 0 in my denominator. So it says make your denominator a power of 10, which would be 10, 100, 1,000, etc., using the same number of zeros from step 1. So my denominator is going to be 10, since there's just 1 0 in the denominator. My numerator is just going to be the decimal 8. And then the final step is to simplify this fraction just like before. So we're going to divide both the numerator and denominator by 2 to get 4/5. So let's go through and do a couple examples. Let's start with 0.7. So 0.7, I can either notice that the last number is in the tenths place, so this fraction is 7 over 10, or I can notice that there's one number after the decimal, so there's 1 0 in the denominator. 7/10 is simplified. There's not a number that I can divide out of both 7 and 10, so I'm done with that problem. The next problem is 0.202. I'm going to notice that there's 3 numbers after the decimal, which means that my numerator is just 202, and my denominator is going to have 3 zeros in it. I could also look at this and notice the last number is in the thousandths place, so my denominator is 1,000. I can simplify this fraction. I can divide both the numerator and denominator by 2, since they're both even. And when I do this, 202 divided by 2 is 101. 1,000 divided by 2 is 500. That fraction is simplified, so my final answer is 101 over 500. Now taking a look at this next problem, we have 0.15 with a repeating bar. That's a special case. So let's move on back up to these repeating decimal special cases. And let's fill this in so we make sure we know what to do with this. I actually mentioned briefly on the front of this page what number we use when we're repeating. So we have 2 different cases that we're going to focus on here. The first one is actually if we just have a single digit repeating, like 0.4 repeating, or 0.1 repeating, or 0.2 repeating. All that we're going to do is make our denominator 9. 9 is our magical number when it comes to repeating. So the number 0.4 repeating, my denominator is 9, numerator is just the digit that's repeating. If it was 0.1 repeating, the fraction would be 1 over 9. 0.2 repeating would be 2 over 9. Our next special case is when we have a multiple digit that's repeating. So that would be like 0.23 repeating, 0.815 repeating, 0.7721 repeating. Here, we're going to match the number of decimals with the number of nines. So this is the same idea as our second way to convert decimals to fractions. When we count the amount of numbers after the decimal, and that's how many zeros we have. So the amount of numbers after the decimal is equal to the number of nines in the denominator. So for example, 0.23 repeating, there's 2 numbers in the repeat, which means that there's 2 nines in my denominator, and my numerator is just 23. 0.815 repeating, there's 3 numbers repeating, so there's 3 nines in my denominator. My numerator is just 815. And this last one is 7,721 over 999. So now let's go back to this example, 0.15 repeating. Now that we know those special cases, we know that our denominator is going to have 2 nines since there's 2 numbers in the repeat, and our numerator is 15. Now we're not quite done with this problem because we can simplify this. We can divide both the numerator and denominator by 3. When we do that, 15 divided by 3 is 5. 99 divided by 3 is 33. That fraction is simplified, so that's all we do on that problem. There's just a few more practice problems left on this. Go ahead and pause this video, work through these 3 problems, and then play the video to make sure that you are doing these problems correctly. So on 0.36, I'm going to notice that the last number is in the hundredths place, which means that my denominator is 100, my numerator is 36. I can simplify this. I can either divide by 2 or I can divide by 4. I'm going to go ahead and divide by 2 because I know that's the first thing that most people notice. 36 divided by 2 is 18. 100 divided by 2 is 50. At this point, I can divide those numbers by 2 again since they're both even still. When I divide them by 2, 18 divided by 2 is 9. 50 divided by 2 is 25. 9 over 25 is as simplified as that can get, so that is my final answer. If I would have originally divided by 4, I would have skipped this middle step and I would have gotten straight to my answer. Next problem, 0.51. Well, I know my numerator is going to be 51. There's 2 numbers in the decimal, which means that there's 2 zeros in the denominator. So this fraction is 51 over 100. That does not simplify, so that is the final answer. And lastly, 0.7 repeating. This is repeating, which means my denominator is going to be 9. There's a single digit repeating, so I have a single 9 and a 7 in the numerator. That is all that you are doing in this section. So if you still have any questions, make sure you come and talk to me, and